Let's talk about food analysis called estimation of moisture. This is a routine food analysis done for different reasons. This analysis can be categorized into two different techniques called drying methods or distillation methods. Normally, in case of drying, we use different kind of ovens, and there are a lot of different types of ovens available in the market, and you would find them in the labs as well. These ovens would normally dry the sample, and they would dry the food sample to an extent where we are not left with any more moisture in the food, and this lost moisture is actually calculated as the percentage of food. And as I said, that food is a complex matrix, so that would mean that this method of moisture analysis must take into consideration the chemistry of food. Like most of the food could be oily or spices, or there could be sugary foods. So we have to follow the procedures according to the type of food for this basic drying operation. One of the simple method is air oven method for moisture content. And in this air oven method, we normally use a flat bottom dish that is routinely used for the moisture analysis. We do weigh this flat bottom dish, and then we add the food sample into this flat bottom dish, and add this sample into the oven, and we do the heating process here at 100 degrees C for 2 to 3 hours. Once we take out this flat bottom disc from the oven, it has to be cooled down in desiccator. A desiccator is an apparatus basically that would avoid the condensation of moisture on the flat bottom disc so that we don't get any errors in the food analysis. Once the normal room temperature is achieved, this flat bottom dish is taken out from the desiccator, and we weigh this into the weighing balance. And the moisture is calculated as weight loss from the food. So the formula for estimation of moisture, we calculate the water in sample divided by the weight of wet sample. That is multiplied by 100. Another way of expressing the same formula is weight of wet sample divided by weight of dry sample. That actually is the weight of water in sample. That's another way of saying, and it is divided by weight of wet sample, as we do have the same formula above, multiplied by 100. So this gives us the moisture content weight by weight basis, and this is how we normally express the moisture content in foods. There are new methods of determining moisture analysis as well, like infrared drying. And the reason for using different methods like infrared drying is actually to speed up the food analysis process, because in industrial situations, most of the time, we cannot wait for multiple hours to get our results. We need the speedy results. So infrared lamps actually heat the sample quickly and remove the moisture content very quickly, because the filament temperature reaches to 2000 to 2500 Kelvin degrees C. So that actually speeds up the removal of moisture from the food. It only takes 20 to 25 minutes to actually remove the moisture content, and the food analysis can be carried out quickly. Now, another method of measuring the moisture content is distillation method. And why we use this method is because some of the food, like milk, would have very high amount of moisture, and it would be literally quite difficult to remove all the moisture by oven method. Because if we dry the milk to that extent where we remove all the moisture, there would be other degradation that would take place in other components of the milk or any other fruit juice or something, a liquid food sample. So that is why we use a different method, which is called as a distillation method. What we do in the distillation method is we use a solvent, and then that solvent, this solvent is normally toluene, xylene, or tetracyclate. This would have normally higher boiling point than water. That would mean it would boil after water. It has got more than 100 degrees C boiling point, and it must have lower specific gravity. That would mean it could float on water. These are water immiscible solvents, so they would not mix up with water. If you just look at the picture of the apparatus for distillation procedure, it have a flask where we add the food sample, and then this food sample is covered with the solvent. Once we apply heat, this heat would actually evaporate this solvent as well as water to this condenser. This condenser normally is provided with the water inlet and outlet to reduce the temperature, and that lower temperature brings this solvent and water down to this flask. This is a graduated flask. So the graduated flask would give you actual amount of water. This process is repeated several times. So whenever there is an extra amount of solvent that comes on the top, that solvent would siphon off again back into the flask. So here you would get exact amount of water calculated directly from this graduated flask. So if we summarize this method of distillation, we are going to add food in the flask, and then this is covered by the solvent. And once it's covered, we distill this apparatus at the rate of 1 to 2 drops every minute. And once we have achieved all the water in the graduated flask, this is washed and measured directly. So these were the two methods for water determination: oven methods and distillation methods.